Hello and welcome to another tutorial of understanding programming concepts. Today we will be looking at the concept of iteration or loops, a very important programming construct. In programming we have several different kinds of constructs. One of them is called sequential programming, where you write a set of instructions that all run in a sequence. Then we have conditional construct, where we put a condition, and based on the condition being true or false, it goes in one direction or the other. Generally speaking, programmers code if conditions, select cases, switch cases in that direction. And today we'll be looking at another programming construct called iteration or loop, which is pretty much a structure that allows repeated execution of a block of statements. So within a loop or an iteration, the condition could be true or a condition could be false. Now there are multiple kinds of loops, and there are different groups in which loops are categorized. So we're going to generically talk about the idea of loops and how some languages behave around loops. So the idea of a loop is that you have a bunch of instructions that you're roaming around. However, this roaming around could be categorized in two categories, infinite or finite. In an infinite, you don't know the ending condition. There is no ending condition except for the fact the loop always keeps running. In a finite condition, the loop thus comes to an end in a known time frame. Infinite loops are not always bad. However, computers cannot think infinitely, so what we do is we pack the infinite loops inside a finite process just to fool the computers. So computers are still thinking that I'm running a finite process, but that finite process holds an infinite process, therefore that finite process keeps running for a long time. However, computer knows that there is a way that they can crush this process whenever they feel like doing so, so they're happy about it. Infinite loops are not always bad in a sense that infinite loops could be used to create an application that will require you to execute it infinitely, such as a radar monitoring system, such as a weather station monitoring system, such as an object in a gaming world that is waiting for something to happen, otherwise infinitely roams around in a plane. Your clock that has to run infinitely until and unless something really goes bad. On the other hand, a finite process is defined by either a finite count or a finite event. So most of these slides coming forward talks about finite categorizations. And other categorizations in which loops could be categorized is called a count controlled or event controlled. When we talk about a count control loop, it's pretty much like something that's going to go on in a cycle. However, we know how many times it will going to go in a cycle. For example, if I have to produce 5,000 units of bolts, I know that I got to produce 5,000 units of bolts. In each cycle, one bolt will be produced. And I know that after 5,000 cycles, I will reach my goal. So that is a count control loop. On the other hand, an event control loop is a different one. An event control loop is driven by an event. So I know when this process will going to end. However, I don't know after how many iterations. For example, if you are asking user to compute a value and you're asking user to give an input, as long as the user is giving an input, the loop will going to keep looping. The moment the user decides that he doesn't want to continue with the loop, that's the point when the loop will going to terminate. So in those kind of situations, things are driven by the user's input. So the user may terminate the loop in the first cycle, may not terminate the loop until the 1500th cycle. So we don't know after how many times the loop will going to run. For example, if you have created an application that is supposed to ask user, what is your investment, so that I can give you back the return on investment. And after every return on investment calculation, it asks user, would you like to continue? As long as the user keeps continuing, he will be in a good shape, that the loop will going to be running. As soon as the user decides he doesn't want to continue, the loop will going to terminate. So the ending of the loop is driven by the condition, but the condition is being controlled by an outsider who is interacting with the loop. So that's an event control loop. The third categorization of loop is called a precondition or a postcondition loop. So all loops, just like if conditions, have bodies. If a condition is at the beginning of the loop body, as you can see in the picture to the left, is called the precondition loop. If the same condition is placed at the end of the body of the loop, we call it a postcondition loop. So we have a precondition loop where the condition is checked at the beginning of the body of the loop, and a postcondition loop where the things are checked at the condition is checked at the end of the body of the loop. Now this is a good time to introduce some loops that are generally used in languages. For example, in Java, C++, C, JavaScript, C#. They widely use for loops, while loops, do-while loops, and some languages will use do-until loop like VB.NET. So do-while is a postcondition loop because the condition is being placed at the end of the loop. Do-until is a postcondition loop because the condition is placed at the end of the loop. On the other hand, the for loop and the while loop are precondition loop because the condition is being placed at the beginning of the loop. So when the condition is at the end of the loop, that means you will still going to go through the body of the loop even if the condition is false, because the loop will not terminate until the condition is checked. Now there are two kinds of loops. This is the fourth categorization of loops. While, for, and do while. These are the kind of loops. They will going to keep looping as long as the condition does not become false. So these loops terminate when the condition is false. So for example, if the condition is to print the first 10 positive numbers. So the condition is as long as the numbers are less than or equals to 10. As soon as the numbers exceed 10, terminate. So as long as the condition is true, the loop will keep looping. As soon as the condition becomes false, the loop terminates. On the other hand, we have loops like do-until that are reverse logic loops. They keep looping as long as the condition is false, and they terminate when the condition is true. For example, if you have to do the same process in do-until loop to print the first 10 positive numbers, you're going to write the condition as do-until the number is greater than 10. That means as long as the number is not greater than 10, keep looping. As soon as the number actually becomes greater than 10, so then the condition will be true, so the loop will terminate. So loop keeps looping as long as the condition is false and terminates when the conditions become true. Now we're going to be looking at the count-controlled loops. The count-control loop is a loop in which you know the count. So you know the starting point, you know the ending point. So those are the two main important things. You just need to tell the user, or you need to write a logic rather, that will going to take that start point to the end. For example, if you had to print the first 5 whole numbers on the positive sides, 1, 2, 3, 4, 5, then your starting point is 1, your ending point is 5. So when you start your loop, your counter is at 1. And your condition is as long as the counter is less than or equals to 5, so that's your end point. As long as the condition is less than, as long as the variable that you are countering is less than or equals to 5, keep looping. However, how to get from start to end, what you got to do is in your loop logic, you got to increment the counter by 1 every time you go through the loop cycle. This is the only way you can go from 1 through 5. On the other hand, if you had to print numbers 5 through 1, now your starting point is 5. And your ending point is 1. So now you got to go through the loop body and decrement 1 at a time. Similarly, we have event control loops that do have a condition of termination. However, we don't know after how many times that condition will be reached. However, we need to code that termination condition. For example, keep looping as long as the user's response is yes. As soon as the user's response is something other than yes, that will going to terminate the loop. So you've written the condition, user response is equals to yes. So keep looping as long as this condition is true. However, then you would have to also code the logic inside the body of the loop that will going to, at one point in time, allow this condition to terminate. If you don't code that logic, the loop will going to go on forever. So these are some of the basic foundations when it comes to loops. Hope you would have enjoyed the tutorial. See you in another tutorial. Thank you for watching.